This is section 8.3. We're going to show that a quadrilateral is a parallelogram. There's 5 ways to prove that a quadrilateral is a parallelogram. The first way is to have a quadrilateral with opposite sides parallel. That's the definition of a parallelogram. The other 4 ways appear as theorems. So we're going to look at 4 theorems in this section. Theorem 8.7 says that if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So it looks like that. If you have the top and the bottom congruent, whoopsies, what am I doing? Okay, where is my pen? I cannot find my pen. This is a disaster. Okay, come on now. Ooh, there we go. There's my pen. So we have our top and our bottom with congruent marks. We have our left side and our right side with the same matching congruent marks. That means that shape must be a parallelogram. Now, since it's a theorem, you have to prove this. And the way you prove it goes back to what you know about triangles. If you draw one diagonal on that parallelogram, that gives you 2 triangles. And they're clearly congruent by side, side, side. So if you can show that the triangles are congruent, then that's obviously going to give you congruent alternate interior angles in both of those places that are going to give you opposite sides parallel. So that's how that proof would go. We may do a proof like that later in this section. Another way to show that a quadrilateral is a parallelogram is if both pairs of opposite angles are congruent. That would have to force that quadrilateral is a parallelogram. So if you have those markings, that means that shape is definitely a parallelogram. Theorem 8.9 is a different type of theorem. If you notice, those previous 2 were converses of things we've already learned. This theorem 8.9 is really its own theorem. It says that if one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. So you have to have the parallel marks and the congruent marks on the same pair of opposite sides. Doesn't matter if it's top and bottom or if it's left side and right side. That will force the shape to be parallelogram. And again, it's going to be the same type of thing. If you draw a diagonal on, you have 2 triangles. If you have parallel segments, top and bottom, then that means these angles are congruent. You have that shared side. So now you have 2 triangles that are congruent by side angle side. And if that's the case, then you can obviously show that the other pair of sides are parallel too. We might prove that one as well. Last one here, Theorem 8.10 says, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So if you see these markings where you have diagonals splitting each other in half, that forces that shape to be a parallelogram. We're probably going to prove this one as well. Let's talk about how we know this is going to happen. Well, you know you have congruent vertical angles. That means this top triangle is congruent to this bottom triangle. We'll call it triangle 1 and triangle 2. If they're congruent, then obviously the top and bottom are parallel because you're going to have congruent alternate interior angles. And then same thing with these triangles over here. We'll call this triangle 3 and triangle 4. They're going to be congruent to each other by side angle side. So you're going to have congruent alternate interior angles there as well. Keep your eyes open for quadrilaterals that have those markings that fit those 4 theorems.